All right, good morning. Happy Friday. It's been a long week. Looking forward to the weekend, as I know you probably are. So the other day we talked about coterminal angles. Those are angles that have the same initial and terminal sides. And we also talked about converting from degrees to radians and radians to degrees. Do you guys need me to do any more problems like those? Because I'm going to continue today with the lesson. This will be lesson 17.1, part 4. Anybody want me to, I think I ended with converting from radians to degrees. Do you want me to do any more problems? Or are you guys okay? All right. Let's continue on then. And I'm hopefully going to finish up today. What I'm going to teach today is not in your book. It's in the pre-calculus book. So I thought I would lead you into some conceptual things about what's going on. And then the assignment on Monday I posted. So hopefully you're not working on it. I want you can work on lesson 17.1. I posted that one also. But there's two practice pages that I want you to wait until Monday. That is angles and angle measure and arc length and sector area. Okay, so I'm going to be covering everything you need to do on those sheets. All right. All right, so when thinking of degree measurement, think of the hour hand on a clock. For example, 1 degree is equal to 1 out of 360 of a complete revolution. So 2 degrees then would be 2 out of 360, which is 1 out of 180. And 360 degrees would be 360 of 360, which equals 1 full rotation. Of the hour hand. So let's take a look at fractional parts of degrees. Now I'm showing you some stuff that by hand, we're not going to do anything by hand. We're going to use a calculator. Okay. So I'm just showing you conceptually what's going on. So fractional parts of degrees are measured in minutes and seconds. Believe it or not. So 1 minute, that's that little tick mark, that means minute. So 1 minute is equal to 1/60th of a degree. And 1 second, so two little tick marks means seconds. Is equal to 1 out of 3,600 of a degree. So for example, let's say we had 31 minutes, I'm sorry, 30 degrees, 47 minutes and 12 seconds. If we were to do this by hand, which we're not, we would say, okay, well, that means 31 degrees plus 47 over 60 degrees plus 12 over 36 hundredths, which is what I gave above. So what you would, so let me put the degrees in here. So if you would get a common denominator, if you got a common denominator, it would be 31.787 degrees. So what I've just shown you, this is a form, and this is called degree minute second form. And it's a key on the calculator called DMS, degree minute second. So this is degree minute second form, and this is another form called decimal degree form. So what we're going to do now is we're going to use the calculator and we're going to convert back and forth. So we're going to convert from degree minute second form to decimal degree form, and from decimal degree form to degree minute second form. Before we do that, I'm going to write a few things on the board here, just to clear up some stuff. On a calculator, you can change an angle from degree minute second form, which is called DMS, to decimal degree form. So here's some notes. Make sure the calculator is in degree mode. So decimal degree form. So I'm probably going to send out a remind message about this because I want to make sure that I didn't go over this too fast. If you're using a calculator, if you're working with degrees, you want to make sure you're in the mode is degrees. So see the black key that says mode? Go to mode. And you see where it says radian and degree? If you're working with radians, make sure you're in radian mode. If you're working in degrees right now, put it in degree mode. So put it in degree mode. All right, so decimal degree looks like this with a decimal and a degree, just like that problem. Another decimal degree form would look like 2.32 degrees. Examples of degree, minute, second would be 31 degrees, 47 minutes, and 12 seconds. Another one would be 4 degrees, 12 seconds, where minutes is missing. And on the calculator, like I said, this is called DMS. All right, so let's see how we use the calculator. So all of you guys are in degree mode, right? So let's use the calculator to change to degree, minute, second mode. Not mode, form. This is pretty easy. Let's say you have decimal degree form 31.787 degrees. Okay, you're going to put in the calculator 31.787. Do not put the degree symbol in. Don't enter the degree symbol. If you're wondering where that is, I'll show you in a minute, because you're going to need to know where the degree symbol is, but not right now. All right, so you're just going to put it because the DMS key recognizes this as degrees. So you're going to put that in, and then you're going to hit the DMS key. So where is the DMS key? It's under second angle. Now, let me talk about something for a minute with the calculator. There are 3 levels on the calculator. Pay attention. The first level is the white level. So if you notice, all the keys, for the most part, except the numbers, are white. The second level is the yellow level. So anything that has yellow is going to be on that level. And the third level is the green level. So if you're looking for the DMS key, you're going to go second, which is yellow, second angle. See it there? That's yellow, second angle. So second angle, and you're going to choose the DMS key. Does everybody see what I'm talking about? Okay, now while we're here, go to second angle real quick. You see number 1 is the degree symbol, and number 2 is the minute symbol. Now the question, in a minute, we're going to need to know where seconds is. So seconds is on the green level. So you see the alpha, the green? If you go to alpha plus, that, see the little tick marks for seconds? So alpha plus will give you the seconds, which you're going to need in a minute. All right, so back to this. So that's all you do. You put in 3.787 and hit the DMS key and tell me what you get.
I got 31 degrees plus 47 minutes plus 13.2 seconds.
That's right. So what we just did is we took decimal degree form and changed it to degree, minute, second form by using the DMS key. Let's do another one. 280.6 degrees. So once again, you're going to put in 280.6 into the calculator and hit the DMS key. And you're going to make sure that you're in degree mode. So what did you get?
I got 280 degrees and 30 minutes, 0 seconds.
That's correct. All right, let's go the other way now. Can I erase this? So let's change to decimal degree form now. So it's a little bit different. So now you're going to have to put these symbols in. So for degrees and minutes, you're going to go to second angle. For seconds, you're going to have to go to alpha plus. All right, so here's what you're going to do. You're going to put in 64, go to second angle and put in the degrees, put in 45, go to second angle and put in the minutes, and tell me what you get.
I got 64.75.
64.75 radians.
Degrees? Sorry.
Is this radians or degrees?
That's degrees.
Then you better put the symbol. Because if you don't put the symbol, I have to assume you mean radians. Remember the symbol, it's real important. All right. How about a negative 125 degrees in 36 seconds? Now listen carefully. The calculator is going to get confused by this. So what you're going to want to do is you're going to want to put in 0 minutes to not confuse the calculator. And so 0 minutes would be a placeholder. Now, if you're wondering, well, why didn't we do this for seconds up here? Because since seconds was at the end, the calculator knew it was 0. But if you have 0 minutes in the middle, if you don't put the placeholder, it's going to mess up the calculator. All right, so what did you get for this one?
I got negative 125.01 degrees.
That's correct. Negative 125.01 degrees. All right, does anybody have a question about how to convert from degree minute second form to decimal degree, or from decimal degree to degree minute second? Okay, does everybody understand the difference between the two looks? This is degree, minutes, seconds. This is decimal degree. If you guys have any friends in fourth period, I think I forgot to tell them about making sure their mode is in degree mode. I'll send out a remind message to all my classes about it, but if you're not in the right mode, you're going to be getting all the wrong answers. So if you're working with like radians and you need a calculator for an approximation, if you don't have your calculator in radian mode, you're going to get all the wrong answers. Same thing with degree. If you're working, like in this case, if you're working in degree mode, you got to make sure you're in degree mode on the calculator, otherwise you'll be getting all the wrong answers. Okay, I'd written some new notes, so whenever I write new notes, I like to annotate them to make sure I'm covering everything I need to cover. All right, let's go to objective 2 of lesson 17.1, and that's solving a real world problem involving arc length. So here's the arc length formula for a circle of radius r. The arc length x s intercepted by an angle theta, which is measured in radians. If I were you right now, I would change my mode to radians because I'm talking about radians and you're in the wrong mode right now. So change your mode to radians is given by S equals R theta. Now, remember that S and R are lengths. So that means that these guys are going to be in inches, feet, yards, meters, centimeters. But don't forget that theta is in radians. It's the measure of an angle. So let me draw a picture for you. So there's your circle, and there's your central angle. And this would be your radius right there, not that whole thing, just to the into the circle. And this would be your angle. This right here would be the arc that's associated to that angle. So that's S. So there's your radius right there, that segment. There's your angle, and that's your arc length associated to the angle. Now, in pre-calculus trigonometry, you're going to have a formula that can be written a lot of different ways. So instead of memorizing a million formulas, you just want to memorize this one, but make no mistake, if you wanted to find an angle, you could write your own formula by dividing by r. So there's your new formula, theta is equal to S over r. Or if you were looking for the radius, you could divide by theta and get S over theta. So there's three different formulas that come from this: S for arc length, the angle, and the radius formulas. All right, let's do a problem. All right, a circle has a radius of 10 inches. Find the length of the arc. Intercepted by a central angle of 120 degrees. So they want us to find the length of an arc, so we're going to use S is equal to r theta. So this seems easy enough. The arc length is equal to the radius times 120 degrees. Only one problem. Remember that the angle must be in radians, right? Can I erase this sign? We have to convert. So off to the side of the paper, we need to take 120 degrees and convert it to radians. So remember that this fraction has to equal 1 so we don't mess up the problem. So we can take and put 180 degrees on the bottom and pi radians on the top because that is equivalent to 1. And now we can cancel the degrees. We can cancel the trailing zeros. And we could say 6 times what is 18, 6 times what is 12. So we end up with 2 pi over 3 radians. So we go back to the problem and say 10 times 2 pi over 3. And by the way, if this was a 9, we could cross cancel. But it's not. So we end up with 20 pi over 3. Nobody is going to understand what that means. Like, a lot of people have heard about pi, but they have no idea that it means pi radians. They just think it's a number. So to make sense in it, you're going to have to put it in the calculator. All right, and you got to make sure you're in radian mode. So go ahead. What is 20 pi divided by 3?
Would it be 20 0.939.
Yep, it's about 21 inches or 20.9 inches. And you want to put inches because remember that the radius and the arc length are measured in units of measure. They're lengths. So the arc, with this information, the arc is about 21 inches. If you measured it with a string or a yarn or something. All right, let's try another one. Okay, a circle has a radius of 6 inches. You know, let's just change it. Let's say change it to 6 meters. Find the arc length that intercepts How do I write that? Find the length of the arc. I think I better stick with that. I was trying to change the wording so in case you see it differently. The English is too hard here. Length of the arc intercepted by a central angle of 45 degrees. So once again, we're finding the arc and we just put the information in. So they're saying the radius is 6 meters and the angle is 45 degrees, but we cannot use degrees in this formula. So once again, we're going to have to convert 45 degrees to radians. Make sure you're in radian mode if you have to use the calculator. This would be 180 degrees and then pi radians. So we would be able to cancel the degrees and then we could say 9 times what is this 20, 9 times what is 5, then we can cancel the 5 and the 20. That would be a 1, that would be a 4. So we end up with pi over 4 radians. So back to the problem here, we have 6 times pi over 4 radians. We can cancel here. 2 times what is 4, 2. 2 times what is 6, 3. This ends up being 3 pi over 2 radians. I'm sorry, 3 pi over 2 meters. And like I said, that's not going to make any sense to anybody. So you would want to put that in the calculator. What's 3 pi over 2?
4.71.
4.71 meters. Or about 5 meters or 4.7, depending on how they want you to round. Okay, are there any questions? I'm done with the lesson. I do want to go over Monday's assignment that we're going to work in Math Wizard teams. Anybody want to ask me about this? All right, let me share my screen with you. See if I can find what I'm looking for. All right. All right, can y'all see this? Okay, I did post this and some of you may have looked at it. Hopefully you're not working on it. The first problems are convert to degree measure and convert the radians to degrees and degrees to radians. So we've done that. 7 through 10 is your decimal degree form to degree minute second form and vice versa. So we did that today. Number 11 is find the measure of each angle. Now don't forget that the red arrow represents the angle. So they're not talking about the green, they're talking about the red arrow. So there's a bunch of ways you can do this, you guys. So go ahead. What are some ways you would figure that out, number 11? There isn't one way. Go ahead, I want to hear from everybody. How would you figure out number 11? That red angle.
I would go from the 270-degree point and then add 80. And then
And then say you're done?
yeah, I think so.
That's one way to do it. So go to 270 on the bottom, right? So go to 270 here and then add 80 more. That's a good idea. Okay, who else would do it a different way?
I'm assuming another way you could do it is by subtracting from 360 by 10.
That's how I would do it. So since you know that down here, this is 80 degrees, 10 more would be 90. So you know that little blue angle is 10. So if you took a full revolution and subtracted 10, that's another way to get it. So who else, good April, who else would do it a different way? Somebody last period said they would take 90 plus 90 plus 90 plus 80, right? 90 up here plus 90 plus 90 plus 80 and get 350 degrees. So the point I'm making, there is no right way to do it. So there's lots of different ways you can do it, like you're going to see in a minute on a problem that I haven't taught yet. So find the measures and then down here, look at that, draw an angle in standard position. So you had a lot of practice with that. State the quadrants. So that's the first sheet. Let's look at the other sheet. Now, I have not taught this, you guys. So they're asking you to find the length of the arc. Well, I taught that. You can find the length of the arc. We just did a bunch of problems like that. But look at this one. Find the area of the sector. Can you guys see my board? Wouldn't area be what's inside? Well, I haven't gone over that. And I'm not going to right now. I want you to go to your Math Wizard teams. And I want you to do number 13 and possibly 14 and 15. What I want you to do is I want you guys to figure out how you would find the area of a sector. And there's no right or wrong way. There's a million different ways to do it. And I'm going to check in to see what you guys came up with. All right, now if you finish 13, you could do a couple more just to prove that you know how to do it. I just don't want you sitting doing nothing. It's 11:31 and class is over at 12:10. So you're going to be working on something. I don't care if you do a couple, I mean, since we're in your team today, you can work on these sheets if you want, but I want you doing number 13 first. I want you to tell me how you did it. If you finish that within 2 seconds, then go ahead and start on these sheets. There'll be less you have to do on Monday. All right, does anybody have any questions? All right, well, I'm going to send out a remind message to everybody, making sure that if you're working with radians, make sure you're in radian mode. If you're in degrees, working with degrees, make sure you're in degree mode. All right, I'll see you in your Math Wizard teams. Well, to find the area of the sector, I honestly have never done this before in my entire life. All right, so find the area of a sector, who cares? But anyhow, so there's not one way to do it. And I wanted to share with you what one team did because I thought this was a really good idea. So they know that 60 degrees is a sixth of the circle. So if you find the area of a circle, the whole area is pi r squared. Remember that? So the area of a circle, of this circle, is 100 pi. Actually, 100 pi square inches. Well, if you take the area of the circle and you divide by 6, because isn't this 1/6? So wouldn't this be 1/6 times the area of the circle? And is it 1/6 times the area of the circle divided by 6? So that would be 100 pi divided by 6, which is about 52.4. So I thought that was a really good idea. Now, I don't know if that's going to work for everything, because what if this wasn't 60 degrees? What if it was 57 degrees? It may not work, right? But I thought it was cool how this group figured out that it was a sixth of a circle. So this is one way to do it. Another group lied to me at first, but then they told me the truth, because I asked them if they looked on the internet, and that's actually what I did, because I've never seen this problem before. So I looked on the internet. Why wouldn't we? It's full of information. The thing you have to be careful of is that looking for something on the internet, it could be true or it could be false. So I was sharing with that group that when I was doing my thesis for my master's, I had to write a book. And so, of course, I was looking for information on the internet. It was really hard to tell what's the truth and what isn't. So it was really crazy there for a minute. I was overwhelmed for like a month trying to figure out what's the truth and what isn't. So it's difficult to pull out factual information. You can't believe everything you see on the internet. You understand that, right? That not everything's true on the internet. So anyhow, when I looked on the internet and when I talked to this other group, they said they saw a formula that looked like this. That's the area of a sector is equal to r squared times the angle divided by 2. And I've never seen this before, but somebody came up with it. And it actually works. So this angle, if you use it, this has to be in radians. So you would take the radius squared, which is 10 squared, times the angle in radians. So you'd have to convert and put the angle in radians and divide by 2, and you're going to get 52.4 square inches. Remember, area is square inches. So anyhow, it doesn't matter how you do it. What matters is your logic correct? Is it going to work, for all the problems? So that's really what you're doing. But great job, the group that did this. Great job on that. I really like this, the way you did this one. And then even the group that used be resourceful. See, when you're with me in math class and pre-calc, you're gonna have to memorize a bunch of formulas. But when you leave me and you go on to college, I don't really care if you remember the formulas or not, but what I do care about, can you look them up in a book? Can you look them up on the internet? Can you find them somewhere? You're not going to remember a million formulas. You're not going to remember this formula, but can you find it somewhere? I've never seen this thing before until I looked on the internet. So, of course I did it. I used it to make sure it works, but somebody came up with the formula for us. That's cool. All right. So remember, do not work on these sheets. So this is for Monday. I don't want you doing this. If you want to work on your lesson 17.1, I did post it. So out of the book, lesson 17.1 and the online problems. But these we're going to be working on in the teams on Monday. All right. Do you guys have any questions about anything? All right. Great job today. Listen, I hope you have a wonderful weekend. Okay. Have a great weekend. All right. Hope you get some rest, and I'll see you later.
Have a good weekend, Ms. Birch. Bye.
Thank you. I'll see you guys. Next week.
Have a great day, Miss Birch.
Thanks, April. Bye, guys. Have a good one.
Bye, Ms. Birch. Have a good weekend.
Bye, Leslie. Bye, everybody.